Hi, I'm Esben, and welcome to this short video lecture on Overlay operations. Overlay operations are key to almost any GIS, so it's important to get the grip of what they do. There are four main overlay tools that are commonly used. There are more overlay tools, and as a matter of fact, you can get along using fewer, but these are the ones that are typically used. When we start talking about overlay operations, remember that they are very much like and or in SQL. So you can use the concept of set theory again, and so that instead of having sets of attributes, we have sets of locations, individual coordinate points. And so the intersection tool, what that does, it creates the intersection of two sets or more sets, where each set is a layer in our map, and it then finds all those areas that are covered by all the layers that are included in the intersect. So it's the intersection of the coordinates of all the layers. That is the output. If you look a bit closer at how the output is, we have two layers in this case, and the output layer here. It's not just the coordinates, the area that is outputted, but it's the unique combination of features from the classes, the feature classes that have been included in the intersection. So the output is not just the area covered by the intersection, but is the unique combination of those features that intersect. The union tool is then just like the union set operation, so it will return the union of the areas covered from the different feature classes. Again, here note that not only do you get the area, but you get all the unique combination of features in this area. So if you look at the attribute table of both the intersect and the union, they by default will have all the attributes from the layers that they have operated on. So not just a set of single attributes, but basically all the attributes from all the layers that have been included in the operation. This means that you often have to be a bit careful about how many attributes you put into these tools, because it can quickly become very confusing with all those attributes, and a good idea is to turn off unneeded attributes before using the tools. The clip and the erase tools, we often call them cookie cutter tools, because what they do is that they have an input layer and then they have a clip or an erase layer, and the clip or the erase layer then functions as a cookie cutter. So in this case of the clip, we have the input layer and our clip layer, and what we get in the output is what was inside the cookie cutter. So the dough inside the cookie cutter. The erase tool is opposite. Here we get the resulting output is the dough that is outside the cookie cutter. They're different from the intersect tool, although they spatially, the output of the clip tool and the intersect tool might look the same. There is one very important difference, that is that the clip tool only returns the attributes of the input layer. The clipping layer's attributes are ignored. The clip layer just defines which area should be returned, while the attributes of the returned area all arise from the input layer. And the same with the erase tool, the attributes and the spatial distribution of objects are all defined by the input layer. So it's nothing like in the intersects and unions where you are doing the unique combination of feature classes. Here we are using one layer to clip or erase. You should also consider what is the difference between using our select by location, as the tool is called select layer by location, and doing a clip. You could think of them as being very similar. We can create an area and then return those that are completely inside. That might seem as if that would be the same as a clip operation. However, while they do almost the same, there are some very important differences. First of all, overlay operations can generate new geometry. So they create by cutting through polygons. The select layers only return existing geometries. They can't alter the geometries. So you will, if you get a select by on lines or polygons and say overlap, there might be large portions of that line or polygon that are outside. And if you're saying using the clip tool, you will have the polygon cut out, so you only get that part of the polygon that is inside your clipping layer. While if you used the select tool, you'll either get only those polygons that are completely in, or the entire polygon that was partly overlapping. So yes, they are more or less similar, and on point data sets it is often more appropriate to use the select layer operation rather than the clip. However, you should be aware also that the selects, of course, they generate selection sets. They do not generate a new file on your hard drive, while the overlay operations, they do generate new files on your hard drive. So overlay operations are generally much slower, but you have got these final files on your hard drive. Selection sets are much faster. You can typically use them when you're talking about point data sets. You probably don't have to use the overlay operations here, but at the cost of that, what you're working on is a selection set and not a final layer. So it is a bit of this or that, but they are similar. They do almost the same, but there are some important differences to note. So let's try and look at an example of how one does in ArcMap. Looking at overlay operations in ArcMap, I have for this video thought of a little scenario where we're going to look at possible locations for windmills. So we have a data set in our called windmills, and here we have the entire of Denmark, and okay, we could put windmills here, but there are restrictions. You are not allowed to put windmills in town areas, byzoner. I'll just load them in. You are not allowed to do them in protected areas. Load them in. There are some special rules around churches. There's an area around the church where you're not allowed to make large constructions. So I'll load these protected areas in. Of course, we have the EU Ramsar, so bird protection areas. We're not allowed to put windmills in them. It's not practical to put windmills in forests, and it's again, like with the church, there is a protection zone around the forest to avoid the visual disturbance of the forest. So I'll load this protection zone in. And finally, it's not practical to create or erect windmills in lakes. So I'll load in the lakes. So now I've loaded a series of layers that restrict where we can use or where we can erect windmills. And if I make the land nice and green, so all the nice green places we are able to erect windmills. All the other places we are not. Of course there can be other restrictions. This green area out here, for instance, is Copenhagen Airport, and there are other reasons why we probably won't be allowed to create windmills in the airport area. So the question is now, can we do the calculation of this? Can we see how large percentage of Denmark can we have windmills, and where do we have restrictions on what we can do? So the first thing we could do is that we could take and create a union of all those different layers that restrict where we can have windmills. So, but before doing that, I will, as I mentioned, try and get rid of some of those many attributes that are in the layers before we use the union tool. So I go into properties of the layer and I find its fields, and I'll turn basically all the fields off because I don't need any of the fields from my lake layer. I'll do the same for my forest protection layers, turn off all the layers attributes. I'll do the same for my forests themselves, and finally the size off all the layers, and the protected, sorry, church areas, protected areas, for the urban zones, I would like, there's two types of urban zones. There are summer house areas and town zones. So I'll turn all off except the zone definition. So now I have hid all the different attributes away, so I don't have to worry about how they are put together, except for the ones down here in my town zone. I now need to find my tool, and I could of course go to search and just type union, or I could go to my catalog and I could then browse down through my tools, down into analysis toolbox, and then the overlay operations, and then we had the union here. So I'll pick the union tool, and then I will add the layers I want to union. I want to my lakes, my protected areas, my forests, my Ramsar areas, my church protection areas, my protected areas, nature protection areas, my zone, town zones. So that's those. Down here it has this one where it says, okay, what do you want to do with the attributes? There are different possibilities. I could say no FID, and that will, as you see over here, that we'll have no attributes except for the FID of the objects. That is in the output feature class. In the only FIDs, it will also include the FIDs of the input layers, and finally there's this one that's called all, where you get all the attributes from the different input layers. We could have chosen to use only FIDs. The one no FID is seldom useful. Sometimes the only FID is a good choice if you don't need any of the attributes. But I needed that zone information from my town zone protection. So I can't use the only FID, but I use the all, and then I have hid all my the attributes I don't need away in the properties of the layers. So I'll click OK, and off it goes. As you can see, I have background processing activated on this computer, so I have this blue ribbon running down here where it's saying that it is doing the processing, and I could work on other operations in ArcMap. If I go to my results window, we can see that in my current session I have a union operation running at the moment, and when this operation is finished in 5 minutes or so, I'll come back and we'll look at the results. The tool has finally finished. There was a bit short pop-up in the corner saying that it was done, and also we can see that it has now icon here in the result window has changed from hourglass to a little hammer, indicating that it has done its job. If we click the plus, we can go back and see messages about it. These can be a bit difficult to look at, especially if they are large, and especially the tools in the geostatistical part of ArcMap generates very large message elements. So here you might want to right click on the message and say view, and we can look at information about what it did, and that it took 7 minutes and 29 minutes to perform this operation. We can also have our output, where was output, which inputs do we had, which environment were we running on, and if we want to redo the operation, we can simply double click at the tool and it will bring up the dialog box so we can rerun the tool. So that was our result. Now let's see what we have in one of these unions here. So here we have our union layer, and if you look at the attributes, the interesting thing to note is that we have the FID for the lakes, the forest, there were some Ramsar areas, the church protection areas, the nature protection areas, and so on and so forth. And we have this, remember that in the town zone layer I left one attribute out, so we have a zone attribute here, so we can see that attributes are included in our union output, and we have our forest layer. So we have at least one FID from each of our objects. Note that it says -1 in almost all of these, apart from the first one. Further down there will be -1s perhaps in the first and not in some later ones. That's because a -1 indicates that this layer, so this layer, this area in represented by this row here, was included because there was a lake there. It was not a forest, it was not a Ramsar area, and so on and so forth. So there's -1s in all of these. There might be some that were covered by many restrictions, and if we want to do that, we can do some of these field calculation operations and combine with some SQL. So let's try and generate a new attribute where we can see which layers were the cause of the restriction. So we have it as a nice text rather than having to look for which column we had a value in. So in order to do that, I'll create a new attribute. So I'll add a field and call it type or restriction type. Restriction type. And I'll declare it as a text, because I want to write text in saying which type of restriction was added, and I might need more than 50 characters, so I'll just increase this to 100 just to make sure that's enough. Good. I'm going to make some this what I'm going to do in the following can be done in many different ways. What I'm going to do is I'm going to use some text concatenation tricks. So I want this to start out with being an empty text string. So I just use the fill calculator, and instead of having the nulls that are in the moment, there's no data, I'll write down a empty text string into each of them. But that's just because I want to do some text manipulations in a moment. While I was doing this, I'll go up into the selection. I can't do it. So now you see all the nulls have disappeared. I'll now go into the selection and do a select by attribute on this layer where my FID from legs is larger, strictly larger than 0. Okay. So all of those rows that had a FID strictly larger than 0, I might even say, I think -1 means it not. So just to be sure, I say larger than 0. I don't think that is a 0 FID, but just to be sure. So I've got them now, they're selected, and I can then go into my little restriction one here and use the fill calculator and say that they have to have the value of the whatever it was in previously. So I could say, doesn't really matter in this case because it's the first one, but I'll be using the same principle all the way through. So I'll say that it has to be what was in the field already, followed by, so using a text concatenation, this case it was lake, or sø in Danish. So give it a lake, and I'll give it a followed with an underscore. So what it says now is that these here, the restriction type, if it was restricted due to a lake, it would take the content of it, which at the moment is just empty text string, and concatenate the text lake after it. Once it's done that, I will go back to this one and say, now I'm interested in that the forest ID is larger than 0. I'll apply that. And I now have my forest element selected. So I'll go over here and do it once again, saying that this time I'm not going to concatenate a lake text, but I'll concatenate woodland, just wood, like that. So now it has this as its additional rule. We might say that, oh well, we had this that was not only wood, but there was also a wood protection line. I could have added them together. Different ways of doing it. But I'll just say okay. And once that's done, I'll do exactly the same for my Ramsar areas. So I'll change this one with the Ramsar. Oops, get rid of that one. Say apply. And these were the Ramsar areas. Choose this field again. Say concatenate what's in them already and add the word Ramsar. And run it again. I think you got the idea, so I'll just pause the video while I do it for the last ones. I'm doing this and I know that this can be done in a wee bit smarter way, but I'm showing this one, and in a later video I will do tricks that can do this a wee bit smarter. But until now, this is a feasible way of extracting the information about not only that the union was of these and these layers, but also which layer was it that was giving the restriction and which layer combination, so that we have, if there are more than one layer that's restricting the eviction of windmills, they might have a higher weight than if there's only one layer restricting the eviction. So, see you in a moment. Now that it's finished, you can see the last one I added was these town areas, and we can see that up in this one here we have that these were wood, Ramsar, nature protection, and so on and so forth. So these up here had several different elements in them. So this attribute over here, our restriction type, now contains a series of text indicating which type of restrictions we had on this area. And if I close the attribute table and look at how we can get rid of the selection set and how we can visualize this, so we can go down on the properties and our symbology and give it the category as defined as our restriction type, add all values. You'll now see that we have all these different combinations of churches and nature protection, and church, nature protection and urban zone, a lake, church protection, nature zone and town protection lines. So that's an interesting one. That's a lake close to a church in a nature protection area that is also a town zone. That's a good place. So we have all these different things, and I can say okay. Of course there will be many of these combinations that are very small areas, because that they are generated what is called gaps and slivers. All of these layers have from different sources, and I've just combined them together, so they're not spatially aligned. So there will be small areas that have peculiar combinations. And of course we could do a filter on our layer that said that we only wanted to have those where the area was more than some limited value, so that we could get rid of that type of problems. We go into our definition query and we could say that our shape area, which should be down somewhere at the bottom here, has to be larger than, and it is in square map units, so let's say that they have to be larger than 100 square meters, and then that could reduce some of those many combinations that we have on our map. So we now have more true double registrations, if you wish. So this is our nice new map where we have all our different ones, and there are some that don't have any values, don't know why, and then we have all our different combinations. We might now want to say okay, this is our combination layer, and this is what's left. How much of Denmark is left? So we could then use different tools for doing that. We could of course use the union again and then take those that only were in one of the unions. So basically you can do almost everything using the union and looking at those FIDs, what values they have. That can be used for both doing intersections. If an intersection of the layers would be those places where those layers have positive FIDs in the union. We can use them for arrays by saying that the FID of the cut layer had to be some negative if you wanted to do the arrays. So you've got the ones outside, or if it's positive, you do the clip, then that would be the same. So you may find that you can do almost all of these using only the union tool. But of course it's more convenient to use the more direct clip and erase and intersect. But if you for some reason need it, you can carry on quite fine with only the union tool. So I wanted to find out how much land there was left, so I will go down and find my clip tool. And as a matter of fact, I won't use the clip tool, I'll use the erase tool because I'm interested in that part of Denmark that is not in the restricted areas. So that's not a clip. A clip is the one that returns what's inside the cookie cutter, so that will just give me what's in the protected areas, while my erase will give me what's outside. So I use the erase, and I'll then say I want to use my input layer is the whole of the country, and my erase layer is this union thing I've made of all the different layers that I've union together. And I can then say OK, and it will run again. Just like before, this will take quite some time, so I'll pause the video and be back when it's finished. Now you saw the little blue indication here that it's finished, and we can also see that the tool has changed from a time glass to a hammer. So we now have this blue area, which is the area of Denmark that can be used for erecting windmills based on these calculations that we have done here. We can, of course, if you want to know how large this is, it would have in here, it would have a series of shapes, but if I click on a layer, I can ask for its, I could of course do a sum of statistics, but I can also ask for statistics, but what I only want is the sum, and I can compare this sum, which is how many square meters of Denmark that you are allowed to erect windmills on, compared to compared to what we have down here in the whole of the country, where we see open attribute table, and then compare this statistics here, which is about just over twice as large. So we are, based on this scenario here, we can erect windmills in around half of the country. We can also, if we want, we can make a bit more clearer view of it, returning of all these different intermediate layers we've been using. This, so here we have the blue area here, which is the area that we are allowed to create. You can paint this on red. So, and this on green. Good. So, the green areas are where we are allowed to create or erect windmills according to this model, while the green ones are where we are not. And of course, in this Copenhagen region, there's not really many places where it's possible. While if we look in Jutland, we'll have larger areas, or outside the Copenhagen region, we have larger areas where we can. This is not saying that they're good places, but just that they are ones that are not against any of the restrictions we have used in this little model. Of course, we'll have to look at wind speed and things like that if we wanted to look for whether they were good places. So we have used the intersection and the union and our erase tool. There are windmills I have in the data set that is also the location of the windmills as they were of August 2015. So this is this data set here. And of course there's some offshore windmills, quite a lot of them. But we can see that they roughly are in the green areas. But are they really when we start looking closer? How many areas of restricted areas are covered by windmills? If we want to find out of that, we will first use the buffer tool, which is described in detail in another video. So I'll just create a, let's say, 500 meters buffer around each of my windmills. So 500 meter buffer, like that, and it will run the tool. Shouldn't take so long. Now I have a 500 meter buffer around each windmill, and if I now want to find out, okay, what restrictions are within that 500 meter buffer, I can go and do a intersect tool. So I'll go and find my intersect. It was up here. So I'll take the intersect of my buffers and my restriction. Okay. So now I'll see which areas are inside the 500 meter area around my buffer and are in restricted areas, and what type of restriction they are, so I can start looking at what type of problems are we facing, because one thing is legislation and planning, other thing is what really happens. Our buffer tool, intersect tool has finished. We can go in and look at, okay, which type of restrictions have been influenced. We can, if we look at the attribute table, we can see that it has this list over here, which has all the different types of restrictions that are because we did a intersect, we will only have elements that are in the restricted area, so it won't tell us how many non-restricted areas are, which type of restricted areas there is. And if we want to have some form of numerical representation of this, we could use our summary statistic tool. So if we, which is covered in another video, which we have up under statistics. So we can do our summary statistics, and we can take our intersection layer, and we can say we want to do a sum of shape area, and we want to do it based on our restriction type layer. Oops, and we have to give it what we want to do, and we wanted to do the sum. So, and off that goes, and we will have a little table where we can see that we have this one. If we sort by which one is the largest, so this one is this one empty one, which we don't quite see what is, and then we have wood, Ramsar, urban zones, lakes as the main types of where we have a conflict between the neighborhood of the windmill and a restriction zone. So that was basically all for my little talk about how to do overlay operations. See you. Bye.